Thank you so much.
And thank you, Maëva. Thank you for your introduction. Hi, everyone. I'm honored to be able to speak at this symposium today. I'm Terabe, the head of the Quantum Transformation Project at Sumitomo Corporation and a visiting associate professor at Tohoku University. As a user of quantum computers, I'm working on various application demonstrations. Today, let's dive into the world of quantum transformation together. I will introduce quantum society activity in Japan and our challenge quantum transformation project today. Firstly, let me introduce myself briefly. I have been an engineer and researcher in the automotive industry for a long time, and I have experience in developing quantum computer applications in the factory and mobility service fields. After that, I joined Sumitomo Corporation, which has a variety of business fields, and launched the Quantum Transformation Project, which aims to create new value by combining these businesses with quantum computers. So, okay, so let's move to the situation of QCs. The time has come for quantum computers to be readily accessible. In the future, there is a possibility that society will be greatly changed by quantum computers. What should we do at such a turning point in time? Why don't you take the challenge with us today? So from now, I will talk about the potential of quantum computers. Have you seen this slide? It's quite famous. Boston Consulting Group published one. This chart said there might be $850 billion market in 2040s. That's a huge impact. This big quantum computer boom started 10 years ago with the news that D-Wave had launched the world's first commercial quantum computer. Just 2 years later, Google and NASA launched the quantum computing AI lab. The year before last, Google achieved quantum supremacy, and more recently, quantum startups IonQ, Rigetti, and also D-Wave recently have been in the news for their SPACs. As you can see, there is a lot of buzz and excitement in the world of quantum computing. The D-Wave quantum computer that triggered this quantum computing boom, called quantum annealing, actually contains two important Japanese inventions. They are an algorithm for quantum annealing and superconducting qubit hardware technology. Quantum annealing is an invention of Dr. Kadowaki and Dr. Nishimori. And the superconducting qubit was invented by Dr. Nakamura and Dr. Tsai, who were at MEC at the time. From the time of such basic research until now, research in the quantum field has been active in Japan. There are now many consortiums in which many companies participate. For example, Quantum ICT Forum, there are more than 30 companies joining, and also QSTER, there are more than 50 companies, and also Tohoku University Joint Research Group, and etc. Sumitomo Corporation, our company, is a member of many of these consortiums, and we are working with various companies, universities, and government to explore applications that utilize quantum computing. Now, let's imagine together what kind of world quantum computers will create. and how they will contribute to sustainability in the world we live in today. The world today has undergone numerous changes due to the digital transformation, shifting from analog to digital. I believe that quantum transformation will happen next. This is the origin of the name of our project. Quantum computers create value in ultra high speed, ultra high precision, and ultra low power consumption for a variety of specific fields. And it is being researched in a variety of fields like finance, chemical, AI, transportation, manufacturing, telecommunications, etc. Among them, I would like to focus on the field of optimization application today, which is likely to revolutionize society. So how exactly will a quantum computer optimization change our society? Let's dig a little deeper. Oh, just a moment. Oh, here is an example with a problem we all face, traffic jams. As we all probably have experienced commuting to work in the morning, on current roads, everyone is self-centered, eager to get to their own destination as quickly as possible. As a result, the dilemma arises that not everyone can reach their destination quickly. This is because everyone gathers on the shortest route to reach their destination quickly. This causes huge traffic jams, and when traffic jams occur, the next shortest route becomes congested. Very stressful, right? On the other hand, let's think about optimizing the traffic as a whole to reduce our stress in the morning. Let's demonstrate my car going from the left, your car from the right, and so on. Everyone chooses a distributed route. As a result, in this example, there are no traffic jams, and we can reach the destination way faster and much happier. This is an everyday example, but if we apply this idea in other aspects of our society and optimize the entire system, we will be able to solve social problems like this as whole. However, this kind of society cannot be achieved with our current conventional computers. This is because calculating optimization globally is extremely difficult. The kind of optimization problem, the kind of this optimization problem is called a combinatorial optimization problem. Even with small variables, the number of combinations can be very large. For example, in the problem of eliminating traffic congestion, if each car can choose one of three routes, the problem is to select the combination of routes that causes the least traffic congestion as whole. In this case, with one car, there are three ways, and with two cars, there are nine ways, but with 10 cars, there are roughly 60,000 ways, with 20 cars, about 3.5 billion ways, and with 30 cars, there are 200 trillion ways. This is a very large number. Of course, the number of cars is much larger than 30 in real world, so we have to choose from a much larger number of combinations to avoid traffic jams. This calculation cannot be done in real time by conventional computers. It may take several hours or even days. But if a quantum computer could do it in a few minutes, we might be able to control all the cars in the city in real time and eliminate traffic jams. So, when will quantum computers be put to practical use? Actually, no one knows for sure. The number of qubits and many other parameters are evolving year by year, and in 20 years, the world will be full of quantum computers, and there will be many applications that can only be done with quantum computers. However, that doesn't mean that nothing will happen until then. In about 5 years, I guess quantum computers will gradually start to be used in applications such as NISQ and quantum hybrid technology. And here is a chart comparing the evolution of IoT, Internet of Things, with the evolution of technology. The evolution of IoT proceeds in 4 steps: monitoring, control, optimization, and autonomy. At first, nothing can be done without data, so it starts with capturing and storing data for the first step. Once the data is collected, AI will be used to recognize and predict, and optimization will be necessary to determine how we should act based on the result of that recognition and prediction. As I explained earlier, optimization is very computationally demanding. So I think quantum computers will play an important role at this timing. In many industries, like smart factory and mobility, IoT is still in step 1 or 2, I think. Therefore, optimization will become more and more necessary in the next 5 to 10 years. So this is the same timing as when quantum computers will be put to practical use. So it could be a good combination, I think. So what kind of applications are being discussed? Here is a part of my book. Sorry, it's only Japanese. However, there are applications of quantum computers run by 13 Japanese companies. These include production optimization in factories, mobility services such as optimal cab dispatch, recommendation optimization for hotel reservations, materials development, portfolio optimization in finance, and ID assignment to radio waves transmitted from communication base stations like 5G. In this way, many industries are demonstrating the use of quantum computers. So now that you have seen the potential quantum computing, let me explain our initiative, Quantum Transformation Project. Until now, massive combinatorial optimization has only been in the world of simulation, like traffic simulation in laboratory. But if it becomes real time with quantum computers, this will change our society. Quantum computers will not only solve traffic jams, but also for many social problems, quantum computers will be changed. This technology will solve many of our social problems caused by such imbalances. For example, while we are throwing things away, there may be people who want it. Solving this problem will lead to less mass production in factories, eventually lowering CO2 emission. The same goes for the problem for food waste, I think. But you may wonder, can the quantum computer really solve these problems? No one knows for sure. There are many challenges to be overcome. But we can take up the challenge now. The quantum transformation project aims to create great value by applying quantum computers to all sorts of social problems, from underground to our outer space. We would be happy to take on this challenge with you as well. So, how do we go about finding future applications for quantum computers? It is said that future user needs are not even known to the users. Therefore, you won't be able to find their needs by simply asking. This is a famous uh, caricature from the University of London, where engineers are confused about the required swing based on the first one presented. After many suggestions, the tire swing was accepted by the customer. Customers cannot tell you what they want in the future from the beginning. Just as no one wanted a smartphone in the days of legacy cell phone. However, if you make a lot of suggestions, they will say whether they are good or bad. Therefore, I think we need to create good applications with hypotheses and various suggestions. So we designed VEP, Web Cycle, which can create long-term future society. The first step is to create a vision that will excite people in the world. This is what Steve Jobs and Elon Musk are doing. The next step is to send out that vision and gather people who share it. This will be ecosystem. After that, we will conduct POC and POB with these partners, update the vision and based on the results again. From there, repeat the process for the second and third round. I believe we can create a future society and ecosystem and business at the same time with this cycle. So here, let me briefly introduce our company, Sumitomo Corporation. Sumitomo Corporation is a large conglomerate company with more than 900 group companies. We have a wide range of business fields. For example, metal products for transportation, infrastructure, like energy, logistics, and smart cities, telecommunications, supermarket, pharmacy, healthcare, etc. So I think we are utilizing these various fields to test out and eventually create a new society I mentioned earlier by using quantum computing. That's our project. So now let's imagine the world 10 years or more in the future. There will be hundreds of thousands of UAVs. UAV means drones that can carry people flying around in one city. Real-time control to operate these UAVs safely and at high speed will be a big challenge. That's where I think quantum computers can be used. This is the Quantum Sky project. For this project, we are collaborating with OneSky, a US startup with high technology in UAV traffic control, and Tohoku University in Japan, which has great quantum computing application technologies. UAV is a general term for drones that carry people to cargo and has various advantages. For example, it moves fast, it is resistant to failure because it works by electrical motor compared to engine, and it eliminates labor shortage in logistics because there is no need for driver. UAVs contribute to sustainability because they travel in the sky with no CO2 emissions and reduce congestion on the ground. Let me show you our first POC result by using our demo movie. So, do you hear the sound of video?
No.
Okay. There's only Japanese caption. Let me briefly explain. This is One Sky's UAV traffic control system. It's a current system. Here, there's a big challenge to control 3D traffic because with radio waves, the real-time situation of weather radio waves should be included, and real-time calculation is needed. So we tried quantum computing to optimize the real-time traffic control. This is a legacy method on PC. There's only 40 UAVs controlled in real time. And also, this version shows the quantum annealer debug machine used. In this case, 70 UAVs are controlled in real time. Current difference is still small. However, in the future, with high spec quantum annealer or quantum gated computer, maybe more advantage we will get. And by using this system in the future, we will save many lives with air ambulance, and also we could change the society because we will change the city because commute time will be extremely shortened. And also, we will provide drone logistic in the future, novel drone logistics in the future. So let's go back to my slide again. So also, have you ever seen this kind of news? And there the power consumption of AI has increased 300,000 times in 6 years. So AI might burn the planet in the future. Quantum computers are ultra low power. In the case of D-Wave's quantum annealing machine, the power is very small, 20 femtowatt for QPU. That's because it's made of superconductivity. Superconductivity needs to be cooled to work, but even including the cryostat to cool it, the power consumption is only 20 kilowatt. If we could replace AI with a quantum computer, we could solve the power consumption problem regarding AI. So to test this out, we are currently demonstrating price prediction in our actual commodity trading business. We have demonstrated price prediction using deep learning on classical computers, but the accuracy was not good enough with classical computers. Therefore, if we can realize a new method of AI using quantum computing, we may be able to achieve even greater accuracy. Even if the accuracy is the same, quantum AI will have an advantage in terms of power consumption. When it comes to electricity, we are beginning to think about ultra-fast supply and demand adjustments using quantum computers. The demand for renewable energy sources, such as wind and solar, is growing rapidly, and they are very volatile. On days when the wind doesn't blow or it's cloudy, these wind and solar powers don't generate electricity. In response to such fluctuations, conventional technologies do not adjust supply and demand quickly enough, resulting in large losses and shortages. If this can be properly adjusted by quantum computers, we will be able to enter an era centered on renewable energy in a better way. We are challenging these problems because we have power plants and electricity retail business globally. These various elements created by quantum computers, such as the one I mentioned earlier, will eventually find their way more and more into cities. We are currently working on a number of smart city projects in the world. For example, we are working on a project to build a smart city covering over 272 hectares in North Hanoi, Vietnam. That's a huge project. These are long-term projects that sometimes take 20 years to complete. And if they are built with today's common sense, they will be obsolete by the time they are completed. 20 years from now, we will need to think about a quantum-ready city with applications for the quantum computer age. If we can put the living lab which demonstrates quantum technology into these smart cities, I am sure that new applications will be created that have never existed before. So now we are discussing this kind of quantum smart city concept in North Hanoi Smart City, etc. And there are still many challenges to be overcome, realize these futures. For example, we need to find a killer application. To do this, we need to conduct a lot of POC with various partners. We are still exploring what quantum computers can do, but it is very difficult to implement it in a quantum computer. The reason is that there are not so many advanced quantum engineers who can implement quantum circuits and qubit models. So now we are also supporting quantum education activities in Japan, and also we are supporting some quantum computing startups like Israeli quantum software startup Classic. They are providing more friendly quantum software application. So this is a final chart. This quantum challenge is impossible to proceed alone. So why don't you join the activity with us? Thank you for listening.
Thank you very much. Thank you very much, Mr. Terabe. That was a great presentation.
Thank you.